Oh, hi there, fellow learners. It's Jen, and I'm at home today. Welcome to my home. When I'm at home, I love to bake. My favorite part about baking is eating. Looks like I'm gonna have to make some more cookies. It's a good thing I have a recipe right here. What do I need to make some chocolate chip cookies? I need butter, sugar, some flour, salt, baking soda, baking soda, this one. Oh no, this is actually baking powder. My recipe calls for baking soda, so I'm gonna grab, there we go, the baking soda. I wonder why I need to add baking soda to my recipe and not baking powder. You know what? I know who I can call. My colleague from Science North, Melissa Rady. She's really good in chemistry. Hello, Melissa!
Oh, hey Jen. Thanks for calling. I really miss hanging out with you in the theater. How are you doing?
I'm good, Mel. Hey, listen, I'm wondering if you can help me out with something. I'm here at home baking, and I was about to make some chocolate chip cookies and noticed that they were asking me for baking soda and not baking powder. I'm wondering if you can help me figure out what the difference is between the two.
Ooh, fun. Baking is the best kind of chemistry. Maybe you should get a few things to help me explain.
I'm just gonna put you down right over here. Go ahead.
You'll need like a couple of cups, some water, baking soda, baking powder, vinegar. Do you have any cream of tartar?
Okay, Melissa, I've got everything you've asked for. What's next?
So when you're baking something, Jen, you're really just doing chemistry. I'm glad you're wearing your blue coat. You're creating a series of reactions that hopefully will have a delicious result. Different processes and different ingredients are going to do different things depending on what you're making. If you want a fluffy cake, you want to have some air in it when it bakes. You can make a chemical reaction with the batter that forms a gas and adds a little bit of air into the batter. So how about we try some stuff?
Okay.
Start off with the water, maybe about a cup of water in each of the two different cups. Okay, so you've got some water in both cups, but you also need the powders. So let's look at the baking soda and the baking powder and make some observations. Maybe measure out a teaspoon each. Do you notice anything about their texture or consistency? Can you tell them apart? You know that I would never say this at work, Jen, but since these are knowns and they are edible, you can taste them.
They taste awful. This one tastes a little saltier than this one.
Yeah, they don't really taste great on their own. So good thing you're gonna mix them up with other stuff to make them delicious. So let's add the two to water to see what happens. First, the baking soda. You can see that it dissolves. It doesn't really have a reaction.
Cool.
Now try the baking powder. Baking powder, it fizzes. The baking powder reacts right away. It's baking soda and it has a few things extra. So at the base, they are a little bit the same, but the baking soda has something extra. So different substances, everything really, have a property that we call a pH. Now, sometimes we say like something's an acid or a base. Those words we're referring to the pH. So both baking powder and baking soda are basic, So that means their pH is high and they can be neutralized by acids, and acids' pH is low. Now, these specific bases, when they get neutralized, when they meet an acid, they produce a gas. So at first we put in that baking soda and it doesn't react with water. A really common chemical reaction we often use as an example of chemical reactions is baking soda and vinegar. Vinegar is an acid. When we mix the two together, they create a foam. So that's that gas being produced, the sign that we have a chemical reaction. So the baking powder fizzed right away. The baking soda didn't really fizz at all. But let's look at that baking soda solution. Can you divide it into two? Now I want to try to add a little bit of acid to see what happens. First, let's try the vinegar.
It reacts. That's so cool. Look at all the bubbles. Looks like a fizzy drink.
Once we added the acid, it caused the fizzing. You want to try something more? You got that cream of tartar. What happens when you add it? It's like a less obvious acid. Okay. So baking powder already has a little bit of acid added to it. So once it encounters the water, it reacts right away. You know how sometimes when you follow a recipe, you're asked to combine wet ingredients and then dry ingredients separately and then put them together? That's usually a recipe that uses baking powder, because as soon as the wet meets the dry, the baking powder starts to react. So if you have the chemical reaction too soon in the process, then all your bubbles will be gone by the time you bake it. So since you're making cookies, you don't need a whole lot of air. So your recipe's calling for baking soda and not baking powder. Different reactions are going to give you different results. And that's the fun of chemistry.
Question, not all reactions in baking are chemical reactions, right?
Yeah, absolutely. Not everything that we do in the kitchen is a chemical reaction. Remember when we just dissolved the baking soda in the water at first? That was just a physical reaction.
I'm glad I didn't have to taste that one, because the baking soda on its own tasted disgusting.
There are actually a lot of reactions that do, physical reactions that do taste really good. Sometimes you want to add air to the mixture, but instead of using a chemical process, you use what I like to call just brute force. You create a physical reaction, like when you whip cream. You're adding air into the cream without a chemical reaction, and that's pretty neat.
I'm gonna whip it! Whip it real good!
So the thing about a physical reaction is that generally you can return it back to its original state. Like if you leave your whipped cream on the counter, then eventually the air bubbles are gonna pop and like you'll just have the cream left over. So that's a little bit of a difference. When you're putting the baking powder in the water, you can't bring it back to what it was before.
No worries, Mel. I don't think my whipped cream is gonna be out long enough for that to happen to it. Wow, I just learned so much about chemistry. Who would have thought that you could do science in the kitchen and that it would taste this good? Thanks, Mel, for helping me out today.
Well, good luck with your baking, Jen. I mean, I really wish that I could be there to eat some of it with you, but thanks again for calling, and we'll talk to you soon. Take care.
If you have an idea on what I should learn about next, let us know by leaving a comment below. The kitchen needs to be cleaned! See you next time on Jen Learns Stuff. Cookies. Cookies.